Thank you. I'm British, I'm not used to high levels of enthusiasm, so don't feel that you need to clap again. But I've got lots to get through. So from that show of hands, it looks like some people have used Alexa and Siri. Has anyone built a voice interface themselves before? A couple, okay. You can sleep through the second half of this, but wake up for the conclusions. So a brief introduction to myself. As Tejas said, I am software engineer of 20 years odd standing. I started as a Java developer, and then in 2008 I joined Capgemini, which is an IT consultancy. So then my work became project-based, and it gave me an opportunity to branch out and play with loads of different technologies, JavaScript, C#, APIs, LoCode, NoCode, ethereum. And then around 2015, I started playing with voice interfaces, which is what I'm going to talk about today. So I think of myself as a bit of a jack of all trades, possibly master of none. And what we're going to do today is we're going to look at how to build a voice interface. So first of all, we'll consider what to build and how to do it. And then I could do a demo, or I could chicken out and play a video. And then we'll drill down a little bit into the code and see exactly how it works. So, okay, first of all, what are we going to build? Let's look at what we can use, first of all. And there are quite a lot of frameworks available, particularly from the big cloud vendors, which allow you to build your own voice interface. And I had a look through some of them. Alexa is great because it's very well documented. There are loads of quick start apps and tutorials to get you going. As a JavaScript developer, it was very familiar to me because you build a model using JSON, and then you can integrate via an API to a backend such as an AWS Lambda, so you can write that in Node.js. The downside of it is it's not available in as many languages. So you can build apps in English, French, German, Hindi, Italian, Japanese, Portuguese, or Spanish at the moment using Amazon Alexa. But if you wanted a wider range of languages, you can look at some of the other offerings. Google's Assistant is quite specifically designed to build a voice interface for your Android app. So I've not done any Android development, so I kind of steered away from it a bit. But again, as it's very, as a developer, you'll be very familiar with it. You build a model in XML, and then you use REST APIs to call the Google backends. And you can use what Alexa has, plus Swedish, Korean, Vietnamese, Indonesian, Danish, and Dutch. So there's a wider range of languages available. There's a Siri kit to build voice interfaces for your Apple products. It uses Swift, if you're familiar with the Swift development language. And they claim to support 21 languages. Azure claims to support 60 languages, but I don't know what support means, because there's a difference to having a database that translates 60 language worth of phrases to actually pulling out the meaning from those phrases. So I haven't had a look at them though. Today's talk is going to be about using Alexa. And the next question is, what is a good app to build for voice interfaces? It's not as wide a range of use cases as you might think. It would be a scenario where you're not using your hands, because it'd be much quicker to press a button, and often it's quicker to actually type than it is to interact with a voice interface. So I was thinking, what about, a chef? Maybe a chef needs a recipe because they're busy cooking or something like that. And then I thought, well, what about a therapist? Because when you're talking to a therapist, you don't want to be typing, you want to be lying back, you want to close your eyes and sort of concentrate on the inner you. So I thought, well, maybe this would be quite a good app to build with Alexa. We're not going to offend you yet. Hang on, I've got a missing slide here. We need this one. Let me just present it from here. Hopefully it won't be missing here. Here we are, yeah. So we want our therapist to be at least pseudo-scientific. And so I was having a look around at how can I build something that does proper analysis. And there was a psychoanalyst called Carl Jung, who you've probably heard of, and he proposed the theory of psychological types. So he believed that you could loosely classify people into a set of different types. And a lady called Catherine Briggs and her daughter Isabel Myers, there's a picture of them in the bottom there, they took Carl Jung's idea and they ran with it, and they generated the Myers-Briggs personality test. You might have heard of that, you might have sat it yourselves. But Myers and Briggs are quite proprietary about their questions and their algorithms, and they don't allow people to use it without paying hefty fees. But luckily for us, along comes the open source community. And the open source community has created this, the Open Extended Jungian Type Scales, the community version of the Myers-Briggs personality test. And so this is an open source list of 32 questions and an open source algorithm that will define for you your personality types. So you can see some of the examples of the questions there. They're kind of A or B style questions. Do you prefer to make lists or do you rely on memory? And you need to answer these questions on a scale of 1 to 5. So if you always make lists, you would answer 1. If you always rely on memory, you would answer 5. And there's the option to pick values in the middle if you're not sure. And then there's an open source algorithm. So if you disagree with it, you can submit a PR to the open source project, which will assign you a personality type. So these are the opposite pairs. So we've got you could be introverted or extroverted, sensing or intuiting, feeling or thinking, or perceiving or judging. And those sets of letters would then group together to form 16 possible combinations. So now it's time to offend you all. I thought, how can I make this a little bit more technology specific? And I thought maybe I could group these personality types into software engineering personality types. So maybe I thought if you're a server-side developer like myself, you might be a little bit more introverted. Perhaps if you're a front-end developer, you're more on the design side, you're a bit more creative. Perhaps an agile coach, you're more balanced, you see the bigger picture. Perhaps you're DevOps and you like to be really in control. Or maybe you're really into new tech and you're really enthusiastic and outgoing about these things. So what I've built is a personality skill that will run through the open extended Jungian type scales questions and decide for you what kind of a software engineer you might be. So now comes the tricky bit. The type scales require an answer in a scale of 1 to 5. But if you're speaking to Alexa and she says, do you want to make lists or do you want to rely on memory, you're not going to answer 4. You're going to go, oh, well, I probably would make lists. You know, you're going to speak English. So how can I translate, not necessarily English, whatever language you speak. How can I translate that to the 1 to 5 scale? And the interesting thing about working with the voice interfaces is how much context you lose. Because basically what you'll get through to your back end where you're writing your code is just the text that the voice interface has captured. So volume is lost, for example. So we can't say, right, well, they said that really loudly, so they must be really positive. We've lost that information. We've lost pauses. So if they spend a while going, oh, let me think about that. That context is lost as well. And all the filler words, the well, that kind of word that we could use to say, oh, okay, they're not so sure about this. All that context is lost. So I couldn't rely on anything like that to convert the text to the number scale. So what I decided to do was to add a secondary question to each question and capture the response to that and run some sentiment analysis across the answer. So if I say, do you prefer to make lists or do you rely on memory? And you say, I prefer to make lists, my follow-up question will be, well, how often would you reply that way? Or are you sure about that? And then I'll capture the response and run some sentiment analysis upon it. And then if the analysis is positive, I can up your score. And if it's negative, I can make your score more neutral. That's the plan. So to use a sentiment analysis API is a simple matter of calling the API, but I think it's quite nice when you do use these APIs to think about, well, what's actually going on in the background here? And if you think about how you might perform sentiment analysis on a phrase and the whole background of the topic of sentiment analysis is really quite mind-bogglingly complicated. So we're all quite familiar with how you might simply break down a sentence with the concepts of nouns and verbs, but that doesn't really help us get to the sentiment of what somebody's saying. And I had a brief look at the kind of top-level subjects that back up sentiment analysis, and it is quite terrifyingly complicated. So there's these concepts of word segmentation about, so we've got the example here, the word studies and the word studying. We know that it's the same core root, but how can a computer figure that out? And the idea of stemming is to say, well, you take the first bunch of letters that are the same. But the idea of lemmatization is to go a little bit beyond that and to say, okay, well, yeah, so we've got study with an I and study with a Y, but I know through inference and reading the dictionary that in fact these are both from the verb to study. So it's quite complex even breaking down the sentence, and then you get to trying to figure out the sentiment of that sentence. So you've got the polarity, the positivity and negativity of certain words. Sometimes it's easy with yes and no, and sometimes it's just not easy. You know, if my son says to me, "That's sick," I don't know what he means. He probably means something positive, but how do I know to take it that way? And then there's everything that you're picking up from sentiment is subjectivity. So you can't just rely on the word good being positive, because somebody might be saying, "Good grief," and so they're not being positive at all. And then you have to consider, are they comparing something with something else? You know, if I say my phone's better than nothing, that's not necessarily a very positive thing for me to say about my phone. And then, is there implicit information in the sentence? So, you know, if you say something is great for the budget, you're not necessarily saying that it's good value, but you're implicitly implying that it's quite cheap. Whereas if I say, "Oh, that's a cheap phone," then I'm being very explicit with the information. Emotion detection, as I said, that's quite difficult with the APIs because we've lost any things like tones and nuances. But then there's the intent. What is this person trying to convey? Are they a newsreader, or are they trying to suggest something to me? So the background of the individual can apply to the sentiment analysis as well. And then you get to the really hard stuff. So you can see we're standing on the shoulders of giants when we use these sentiment analysis APIs, and there's huge amounts of work that have gone into figuring out how to use languages. I like to think about how it actually works behind the scenes. So most of them should work with a neural network that's been trained. You can build your own. There's a Python library, the NLTK, where you can build your own natural language processing toolkit. Or the easiest way is to use third-party APIs. And I like to think that the APIs, perhaps it's just a phone line that goes through to an old people's home, and they just pick it up and go, "Yeah, that sounds positive," because I think that would be a lot cheaper and easier to implement. Okay, so let's have a look at what this application looks like. We've got two options here. Either I could get a willing volunteer from the audience to come and be analyzed by Alexa, or I can play you a video of my daughter going through the process. So if there's any volunteers that would like to come up and be analyzed, raise your hands. Oh, yeah, okay, lady on the beanbag. We've only got 6% batteries, so I hope this is quick. Okay, so this you can see is the Alexa development environment. It's a web-based IDE, and I can just launch Be My Psychiatrist, and hopefully this will play. Check we've got internet. Oh, I don't have sound. Oh, yeah. Have you got sound from the laptop? Because that should have played a sound.
Can you check on something? Yeah, it's there.
Okay. So how you need to talk to it, I'll show you. You need to hold the button down and then speak. So if I just show you, you go to Start Quiz, and then it will pick up your words. And then unfortunately, you can't hear it, but you'll have to read the blue text here is what Alexa is saying. So she's going to ask you some questions. Do you prefer to make lists or do you rely on memory? So yeah, just hold it down and give your answer.
I prefer to make lists.
Are you sure about that?
Yes, I'm sure.
Okay, now, are you skeptical, or do you want to believe?
I'm very skeptical.
Okay, now, how about time alone? Are you bored by time alone, or do you need time alone?
I need time alone. I need time alone.
Are you sure about that?
Yes?
Okay, now, do you accept things as they are, or are you unsatisfied with the way things are?
I'm not sure. Depends on the context.
Okay, now, do you keep a clean room, Or do you just put stuff wherever?
Depends how tired I am.
Interesting. Would you always answer that question the same way?
I don't know, it's the first time I've answered that question.
Ah. Would you necessarily say that all the time?
No?
Oh,
No. No.
Thank you for taking the quiz. Your personality type is I, S, T, J. We guess from this that your strengths lie in server-side development.
Thank you so much. So that was only 5 questions out of 32. So unfortunately, that isn't your real personality type. You'll have to go and drill down into more detail. But maybe she just knew. But I think what we can see from that is maybe it's not the best voice interface. And asking those double questions is really tedious. Can you imagine going through 32 of those? You'd have smashed Alexa against the wall before you got to the end, I'm sure. So now what we're going to do is have a drill down and have a look at the actual code and see how this was done. Where's my other slideshow? That one seemed to be working a bit better. Okay, so first of all, we're going to look at the levels of the Alexa skills. So there are basically 3 layers. The first layer, the Alexa voice services, is normally the piece that's built into your hardware. So if you buy an Echo, the Alexa voice services will be built in. You can download and install it, or you used to be able to. But what this piece does is it just basically captures the voice. So there's this concept of a wake word. So there'll be a microphone constantly listening for the wake word. It's Alexa. You can change it. Last time I checked, you could only change it to computer, though, so there wasn't many options. And there are rules when to start and stop the recording. So some voice interfaces will let you record indefinitely. I think Siri used to do that. But Alexa will only capture a small amount of time, so it won't consistently listen. And then what it will do is create a sound file from what it's captured and send it through to the Amazon server. So the server, the next level, is the invocation model. The Alexa Skills Kit is what the ASK stands for. And I think of this bit as kind of like the sieve, which takes the text file and sieves out the words that it's going to pass through to your backend for processing. So this is where it tries to pull out the pieces that the user's interested in. And there are a few concepts that we need to know about when we're trying to understand how to build an invocation model. So there's this concept of an invocation phrase. How is your user going to start interacting with your API? So we had start quiz to trigger the process. And there's the concept of an intent. And you can think of an intent as mapping one-to-one with a function that you're going to write on the back end. So if I wanted to write something to turn the lights on, you know, that intent would be the user wants to turn the lights on, and then in my function I could program how to actually do that. And so related to this intent, you can add a list of utterances, which is what you think people might say to fulfill this intent. And you can give Amazon a list of quite a few of these. And the more you give, the more Amazon is able to correctly interpret what your users are saying. So they're not essential, but the more you give, the better it is. So with mine, for example, you might just give the answer directly. I like to make lists. So you might say, I think or you might just say, probably lists. So for my utterances, I've got to pull out what do I think they might say and define what those core pieces of information are. Then there's a concept of a slot. So a slot is a variable in your intent method. And so in my case, the slots need to be the A or B answers. So they need to be making lists or relying on memory. And your slots can have a type. So this can be very simple, you know. So if Alexa says to you, do you want me to put the lights on? Yes, no, that's a type. And I know there's only 2 variables that are going to fit into it, and it's nice and simple. But you can create your own custom types, which is what I had to do for my Alexa skill. So I had to create custom types of all the possible things that people might answer with. So we can have a look at the reams of JSON I created for that in a minute. But Amazon has a lot of built-in types, more than you might think. So there's a built-in type for first names, there's a built-in type for cities, there's a built-in type for weather. You know, you name it, there may well be something that Amazon has already gone to the painful trouble of engraving every possible answer for you. So that's really great for now. So once you've pulled out from your file, of your sound file, the words that are actually relevant to your skill, these get sent through to the back end using an API. So you can wire anything into a back end, but being on the Amazon platform, it's very easy to wire in an AWS Lambda. So that's what I did. These are event-driven functions. You need to define 2 methods. You need a can handle method, which will say whether or not your backend can handle this intent. And then you need a handle method, which will actually complete the logic that you want that intent to do. So at this third point, this is where I could then call out to my sentiment analysis APIs once I had the data. Because we're developing in the cloud, security should always be at the forefront of your mind. So you link these skills to your AWS account, and it's very easy to use OAuth. It automatically uses OAuth between the invocation layer and the back-end layers. And you can use AWS roles and permissions to allow it to speak to your Lambda layer. And so as a generic rule of building stuff in the cloud, always use the minimum permissions necessary. You know, if it only needs to read from a database, don't give it write access, that kind of thing. So always bear security in mind and keep things as locked down as possible. Right, so if I switch back over to the Amazon IDE here, you can see we've got our build view. So the build view is basically, it's a front over the JSON model that we have for our API. So we have our invocation name. This is what we say when we're actually starting the skill. And then you can see our intents. Amazon will give you a bunch of built-in intents here. So we've got cancel, we've got help, stop, navigate home. Those will have default functionality that does pretty much what you'd expect, or you can change it so you can put in a custom help message, things like that. And then we've got that intents that I have defined myself. So we've got the quiz intent here. And here's my list of sample utterances, what people might say. And all this does is basically launches the application and will ask the first question. So we can go and have a look at the actual code behind the quiz intent here. So here we are. So as I said, we've got the can handle method, which says, is this a quiz intent? If so, I can handle it. And then we've got our handle method. And what the handle method will do is basically get a question from my array of predefined questions, which are in my model, which is here. So in the model, I've had to define absolutely everything possible. So I've got all the possible answers. Oh, that's my JSON, isn't it? The model. Yeah, here we are. So there's all my personality types and how they map through to software engineering types. And then I've had to create a model for all the questions that I want Alexa to ask. So start quiz simply pulls one out and asks the user. And then the next intent that we've got here is the answer intent. So how is the user going to respond? They're going to answer the question. How are they going to do that? They might just say the answer, or they might frame it with a I think, or usually, or something like that. So I tried to create some suggested utterances. And then we've got a slot type here. So the slot type that I've called quiz answer, or a bit uninventive with the names, is of type assertion. And if we go down and have a look at the slots here, here's assertion. And I've had to create a list of values for this slot based on the outputs of the quiz. So everything that they might say, the actual piece of information I'm interested in, so the bit memory or lists, I've put it into my slot type. And so then if we go and have a look at the code for the answering, it will pick up the answer. You get a session, so you can store the answers that your user sets into your session here. So I'm basically just finding the answer. If they've answered on the left-hand side, I prefer to make lists, I'll give them a 1. Otherwise, I'll give them a 5. And then I'm going to pull from my interesting responses one of the random answers. So my interesting responses, I think they're also in here. Interesting, I see. Things a therapist might say. And then it's going to ask that back to the user. So then we can go back and have a look at that assertion intent. So this is when the user is answering the "Are you sure?" question. So I created a custom slot called a decision, and this is the utterances of how they might use that decision. And I've given the decision a slot type of assurance, and then I've tried to guess the kind of things people might say. I'm very confident, or probably, yes, no, putting in some of the answers that they might give there. Right, so then going over to the code for this one. So the assertion, here's a really complicated bit where I get the open extended Jungian type scales algorithm. So I've got my number. First of all, I'm going to call out, in this case, I'm calling Amazon Comprehend, which is a sentiment analysis API from Amazon. So you just set it up with your credentials and send it your data, and then it will return a string which says positive or negative, so I can extract 1 for positive and -1 for negative. It will also return mixed or neutral, but that's fine. I can just leave those as a 0. So then I'll change my score and set the score here. And then this is where I've only asked 7 questions because it was extremely painful going through them, but it would actually be the whole length of the array, and then you go through them all, and you finally calculate your answer. So yeah, as you can see, it's a really nice IDE to work with as long as you've got internet access, and you can test it online, as you saw with that lovely test API that shows you exactly what the different layers have captured, and you can see the JSON of what comes in and out as well. So it's really great to work with from a developer point of view. Right, let's go back to the slides that work. Right, we looked at the code. Okay, so lessons learned. When should we be using voice interfaces? So the first thing to think about is the interaction is slow. The triggering the thing, getting it to know what you want. It's always going to be quicker to click a button, and it's usually quicker to type. So the scenarios is when something isn't within hand reach, or when people are perhaps busy with their hands. So it's quite good for small input and output for things you can't reach. So the one that we always use in our house is turn the lamps on, because instead of having to go around leaning over each individual lamp, that single voice command, which can't really be misinterpreted, works quite well. But as you can see from our psychoanalysis, that double question piece of trying to get enough information really slows it down. So when you're thinking about how to design a user interface, you've got to think about minimizing what the user needs to say, and minimizing the sort of openness for interpretation. So what I think of as the voice interface development skills are understanding conversation structure. I think there's quite a lot of language knowledge that is necessary if you're going to build a voice interface. This is obviously language and culture specific. I'm always thinking of it in English, but it's going to be completely different when you're building interfaces in other languages. And this really important concept of a closed question. So, if I say, do you want tea? The answer is yes or no, pretty much, isn't it? But if I say, what do you want? I can't possibly try and encapsulate in my model of intents and slots what your answers might be, because they're too great. And Amazon used to have the concept of an open string literal, so you could just capture a bunch of text. But they're actually discouraging the use of that now, just because it just is too difficult to process. You need some context around the words that you're capturing. And I really think it works well to use a bit of randomness in your interaction model to give it a more realistic feel. So, when my Alexa therapist is saying, you know, are you sure about that? If they said the same thing every time, it wouldn't be as engaging as the fact that I can change it out and say, would you necessarily say that all the time? Instead, so just a little simple piece of, don't just always say the same thing, use a random selection of things which can convey the same closed question, can make it more realistic to interact with. And then just the golden rules of the Internet of Things would also apply to voice interfaces. Always consider security because we're going over APIs on the internet, and always have a manual override. You know, if the only way to turn on your lamps is via Alexa, it's going to drive you mad. And how many of you got a lamp that works with a special remote control and you lose a remote control and that's it, the lamp is completely useless. So there should always be a button somewhere. And then, yeah, be aware of offending people. The first time that I tested this on my software engineering manager and classified him as a front-end designer, he's never forgiven me. So, yeah, be aware that you know, you're capturing data here. You can be capturing sensitive data. You need to be aware of how you store it, how you treat it, and whether there are any biases in the way that you've written your code, based perhaps on your language or your culture, that might not convey what you think to other people. So that's it. Thank you very much for listening. This is the GitHub repo. If you would like to download the personality quiz and subject your family to it, do have a go. It's pretty straightforward to use, and I'll be around if you've got any questions later.